Oh, so hey, sorry, I didn't see you there. Never mind that. Today we're going to talk about actually two lessons from the book. It's one lesson in the book, but I feel like almost like it should be divided into two things. This first one, though, is going to be very easy. It's solving in terms of a variable. You've already had practice with things like 2x equals 6, and you solve in terms and you get x equals 3. That's in terms of x. What happens, though, if we had like 2x equals m? And they'll always say solve for, and they'll tell you which variable to solve for. Solve for x. So all that this means is simply we're going to get x on one side by itself, and we're going to move everybody else to the other side. Okay, so it's not a huge complicated thing. It's just something you maybe not be familiar with. So if we had 2x equals m, of course, to get x by itself, I'm going to divide by 2, and x equals m divided by 2. That's solved for in terms of x. You could go the other way, and if they said solve in terms of m, well, that would be a very simple problem because you already have it in terms of m. M equals 2x. If they gave you anything more complicated, x, y, z equals 6 plus, x. And they say solve in terms of z, for instance. Well, it means you leave z where it is, and you move everybody else away from z. And we're multiplying, so we're going to move it over to that side, and we're going to divide. Okay? So your final answer is z equals 6 plus x divided by xy. And that's all you can do. So solving in terms of a variable, it just is a fancy way of saying get whatever variable they say on one side and get everybody else away from it. Now, the second part of this lesson, and you may have done this might be review, but I find this an incredibly useful skill, and I guess I just want to teach you it now since we're going to be using this in this section, and it'll come up later on. They call it dimensional analysis. Dimensional analysis is just basically converting units, okay? And what I find when people are doing this is they tend to try to do it all in their head. And they're like, 8 centimeters is how many kilometers? And they're like going, well, do I multiply by 100 or do I divide? And it becomes this big thing in their head, and they don't know what they're doing if they're dividing or multiplying. And so this is just a standard way to convert units. You can convert them from anything, and you don't need to worry about whether you multiply or divide. You just simply let the fractions tell you what to do. So let's do a sample, okay? If I had 2 inches, and I want to know how many centimeters that is. All I have to do is I have to think, okay, I've got inches, and I want some conversion between inches and centimeters. Or if I don't know one between inches and centimeters, something that's closer to centimeters at least. Well, in this case, one of the standard conversion things you should know is that 1 inch is the same as 2.54 centimeters. Just commit that to memory, and that'll come in very handy for the rest of your life. Until the United States wakes up and we all go to the metric system, and you don't have to worry about it anymore. But at least until then, now I'm going to multiply this conversion by our original number. And when I multiply it, I'm going to want the labels to be on opposite sides of the fraction. Because just like anything, if I had 6 over 6, I can almost just pretend it's not there, get rid of it, because it really turns into a 1. So I guess I should make that more clear. If I had 6x over 6, I can pretend it's not there because 1 times x is just x. Okay? So I'm going to try to get these labels to match up like that, top to bottom. And then I can just slash them away and get rid of them, and I'm hopefully moving closer and closer towards centimeters. So I have two choices. 1 inch is the same as 2.54 centimeters, but you know that that is the same as 2.54 centimeters is the same as 1 inch. Well, which one do I want to choose? Do I want to choose A or do I want to choose B? And here's what you need to think about. Inches here is on top. If I made this a fraction, it'd be like that, right? So inches is on top. I don't want to multiply it by the one where inches is on top, because then inches will be multiplied times inches and I get square inches. I don't want that. I want to cancel away the inches and get something closer to centimeters. So case B is going to help us do that. They usually do it with X's. You can do dots for times, doesn't matter. So I'm going to put case B, 2.54 centimeters over 1 inch. Now, do you see that inches, when I multiply this together, it'll be on top, and inches will be on the bottom, so inches will cancel inches. And I'll get 2 times 2.54, which looks like it's 5.08, and I end up with centimeters on top, which I want it to be. And so 2 inches is 5.08 centimeters. You didn't have to worry about whether you're multiplying or dividing. You just let the fraction tell you what to do. You know that with fractions, when you're multiplying them, you just do top times top times top, divided by bottom times bottom times bottom. So don't worry, you don't have to keep track. Let's do a little more complicated one. Let's say I had 6 centimeters. And I'm going to eventually want to turn that into how many meters is that? Oh, no, sorry. Not how many meters. Let's do a U.S. system one. How many miles? So maybe I should move this over because I think this is going to be a little longer. So let's think about a conversion between centimeters and something closer to miles. Well, I don't know centimeters to miles, but the one that I just told you at least gets us from the metric system to the US crappy system. Okay? So let's do 2.54 centimeters and 1 inch. Now, am I going to want 2.54 centimeters over 1 inch or 1 inch over 2.54 centimeters? Remember, I want centimeters, since it's on top here, I want it on bottom of my conversion. So I'm going to want 1 inch over 2.54 centimeters, because then centimeters cancel centimeters, and inches is closer to miles than centimeters is. At least it's in the right system now. So now I need a conversion between inches and miles. Well, I don't know that off the top of my head, but I do know that 1 inch is 12 feet. 12 inches is 1 foot. Now again, do I want 12 inches over 1 foot or 1 foot over 12 inches? And I just have to make that little decision every time. I'm going to want 1 foot is 12 inches for 2 reasons. Because now inches will cancel inches and feet is closer to miles. And then I just have one more conversion here. I know a conversion between feet and miles, and probably you do too. 5,280 feet is 1 mile. Do I want to do it like that, or do I want to flip it? Again, feet wants to cancel feet, so I need that on the bottom. So I'm going to go like this. And I'm going to go like this. Feet cancels feet. And I'm left with miles on top, which is what I want. So everything lines up and it looks good. So now I just have to do the brainless exercise, and you can have your calculator. This is what the calculator is really handy for now. You've used your brain to set it up. And you just go 6 times 1 times 1 times 1, which is 6. And you go 2.54 times 12 times 5280, which is who knows. And you do 6 divided by who knows, and you get a decimal from us, or you could leave it as a fraction if you wanted. Okay? So the thing that I really want you to see, though, is the method for setting it up. We're starting with what we have. We're going to this destination, and you just have to keep track of where you're going. You want to cancel units when you can and get closer to where you're going. It might take you 10 different conversions. That's okay. Just keep putting them in there. Just convert, 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 convert. And at the very end, you're just going to simply do top, 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 and bottom times bottom times bottom times bottom, and then do a division at the end, let your calculator do the work, and you'll get an answer. Okay? So that's dimensional analysis. You'll use it a little bit in this section, and we will use it the rest of the book. So this is really a handy method. You should know how to do this. Okay.